In this section, we're going to take a look at SMTP packet structures. I'm going to open a trace file called smtp-normal. Now, SMTP traffic by default uses port 25, and it sits on top of the TCP header. So here we can see the three-way handshake occur, and now we see a response coming from an SMTP server. And SMTP uses response codes, such as this 220 code, and another one that you'll see further on that's a 250 code. From the client side of things, the client uses commands. So here's a command from the client saying receipt. Here's another client command saying data. Here's another client command saying quit. So just as in many other types of TCP/IP based applications out there, the client side uses commands and the server side uses numbers to respond. Another example of that would be, for example, FTP or HTTP. The three types of packets that you'll see in SMTP traffic will be most likely the client side of communications, and this will start right after the TCP header. So where the TCP header ends at offset 3.5, our SMTP commands would start directly at offset 3.6. I'll close that window. So here's the command that goes out from the client. That's one format where the client sends the command. Another would be the response format from the server, where the numerical code sits right after the TCP header. The very first byte contains the numerical code coming back from the server. Now another one would be when data begins to get transferred across the wire. So here we can see the user sends the data command. The server responds with a numerical code, which means start your mail input, end it with a carriage return line feed. And then we have the SMTP message body packets. The message body packets, again, the message body begins right after the TCP header. We can see SMTP is directly after that. And the first line that you'll see will be a from : beginning that line. As you click on this message line, you'll see that unlike so many other fields and areas inside of Wireshark, this one does not have a display filter value for a message line. If we go to the command area, we can see that the command line does have a filter that we can use. But in SMTP, we don't have that. It's a little different when we get to the messaging area. In the next section, we're going to look at how to filter on SMTP traffic. Capture filter, display filter, and a filter based on specific commands or specific response codes. First, we're going to build a capture filter for SMTP traffic. I'm going to click the Capture Options button, bring up the Capture Options window, and I want to see if there's an existing capture filter built for SMTP traffic. So as I look through this list, I don't see any, so I'm going to have to make one. So I'll create the filter, called it SMTP, and SMTP uses port 25 by default, and it runs over TCP. So the filter syntax would be TCP port 25. I'll click OK. There it is. Now at this point I could run this and capture the SMTP traffic on the cabling system. But first I want to show you how to filter out SMTP traffic. I'm going to cancel this window out and open up a trace file called pop and SMTP. Now in this trace file I've got some pop traffic and I've got some SMTP traffic. I also have some messenger traffic. I've got a lot of junk in here, some DNS traffic, some DHCP traffic, etc. The easiest way to build a display filter for SMTP is just to type in SMTP. Wireshark recognizes all the protocol names that are listed in the protocol column, so we can use those names to build quick filters. I'll hit enter, and now I'm looking at the SMTP traffic only. Now, if I wanted to, I could also build a filter looking for specific commands in the SMTP traffic. So perhaps I'm interested in all of the times when the data command crossed the cabling system. I can right mouse click on that command line and say apply a filter based on the selected value, and I can see only once in that entire trace did the data command cross the wire. Once I know that syntax, then I can apply other filters. Let me show you where the list of possible commands are for SMTP communications. I'm in RFC 821 at the ietf.org website, and the commands are listed in section number 4. So I'm going to go down to the SMTP commands section. It's section 4.1 that it begins in, and you'll see a wealth of information about the different types of commands. So here you can see the hello command, HELO. There's the mail command, recipient command, the data command. So each of the commands are documented in there. One of the commands that you may see that's not documented in this RFC because it's so old is the EHLO command. The EHLO command is just like the hello command, except that the server can provide additional information back to the user when they talk to that server. Besides just giving the server name, they can also give a list of the various commands that they will process. Let's go back to the trace. I'm going to clear out this filter, and this time I'm going to use Wireshark's expressions to build an SMTP filter. So I'll click the expression button, and remember this will append to whatever might be in your filter window, so you want to have that cleared out. I'll type in SMTP, expand the selection, and here you can see the different areas in SMTP communications where you can build filters. There's your command listing, there's your response codes equal to, and then you'd put in a value. In addition, if you find a packet that has a response code that you're interested in, such as the 354, you can simply right mouse click on that field and apply that as a filter, and it'll pull up just the packets that have that response code in it. We're going to examine normal SMTP communications by opening up a trace file called smtp-normal. Now, as you learned in the first module of this section, SMTP sits on top of TCP. So we have the TCP handshake going out to port 25. Once that's completed, then the server responds with a code 220. Now I'm going to take you out and show you all the code numbers for SMTP communications. I'm in RFC 821, and I'm in section 4.2.2, which provides us with a numerical order list of the reply codes. Now the section before this provides them grouped together by function, but most of the time you're probably just going to look them up in numerical order. So here we can see this is 250, and that's what we really want to see most of the time. 254, start with your mail input. We'll see that in the background as our user starts sending mail. You can also go up to the 500s. This has typically the 500s are associated with problems that occur, and same thing with the 400s. So now let's go back to the trace and walk through this SMTP communication where this user is sending one email message. The first command that the user sends across to the server is the EHLO command. Now the difference between HELO, hello using HELO, and EHLO is that EHLO provides us with extended information about the server. If the server supports this, it can send back not just its name, but also a list of all of the commands that it will support. From a security standpoint, however, you may not want your email server to tell someone who's connecting to it all the possible commands that they could execute on that server. When the client sends out the EHLO to the server responds with a numerical code 250, and this is the response parameter. This server only gives its name. The client acknowledges receipt of that, and then from the server we will get a little bit more information. Now this information here, the size command can be used if a server is going to limit the user in the size of email messages that it will allow the user to send. If there's no limitation, you'll see the setting of size 0. In addition, this system is set up for pipelining. Pipelining simply means that the client doesn't have to wait for responses from the server before sending the next request. At this point, the server has given us the basic information about itself and the basic settings, and now the client is sending a command saying mail from, and it provides its own email address, the client's own email address. The SMTP server is going to check on that and see if the sender is okay, if that value is recognized and all right. Now the client says who it's sending the packet to, who it's sending the email to. The server responds and says okay. And now the client says, I'm going to start sending you data. Now the server at this point should send back a 354, which is the start mail input response code. It will tell the user to end with a carriage return line feed, carriage return line feed. In packet number 15, we see the message starting to come down go up, I should say, from the client to the email server. All of this header information is placed on the email by the client email program itself. So we can see that this client email program they're using is Microsoft Outlook. We can see it's a multi-part message, MIME format. We can see the date information. There's the subject line. There's the from and the to. And then we start seeing the message come across in ASCII text. At first, this content type is text, plain. So we see it being sent up to the server in just plain text format. These are the carriage return line feeds, all these /r/ns. And that's the end of that packet. We'll go on to the next packet. And in the next packet, we see that the user is beginning to send across HTTP information. Well, actually, it's HTML code. This email is going to be sent in two formats, both text and HTML format. So here's all the HTML formatting information to go with the message. And then the next packet, we see the message come across, this time with the HTML coding in the message. So here we can see the end of the message. This message is intended for use of the addressee. That's the sign-off area of the message. Now the server receives that, and client sends an end of message notation saying, okay, that's it. That was all I had to send. That's the end of that message. And the server acknowledges receipt of that and then sends back a response code 250 saying that the message has been accepted for delivery. This is where we don't want to see any of those 400 or 500 codes show up. Now the client has finished sending its email and it finishes off with the quit command. SMTP server acknowledges that by sending a response code of 221. In the 221, the server is saying that it's the service closing transmission channel. So the server is going to close the connection. The client has already started that because we can see the fin up there. Then the server responds back saying, okay, we're going to close this channel, and then the client says goodbye. It sends a reset up to the server. The server is sending a FINAC back in response to the original client fin, and then the server sends the reset to completely close that channel. And that's a normal SMTP communication. One of the things you'll notice as you look through there is that there's no login and there's no password involved in this process. Right from the beginning, we see the client just talk to the server and start sending the mail. That's why a lot of email programs, client programs, link the sending of email to the receiving of email. So you have to log in to the POP server first before they'll ever allow you to send any packets, and they'll group those things together. Now I want to show you some unusual SMTP communications. I'll show you what it looks like when an SMTP server is down, and I'll show you what it looks like when somebody runs an SMTP verify command to see if an email address is valid. And then finally, I'll finish it up with an SMTP relay test, somebody running an SMTP relay test on the wire. most of the time when people complain about poor performance in sending emails, I've found that the majority of the time it's actually something happening at the transport layer. So if we look down at the TCP communications, we would see retransmissions and lost packets and things like that. The first trace I'm going to open up here is called smtp-fault. In this case, we have someone that's ARPing to get off of the network. We see some DNS queries, and this is going out to our packetlevel.com SMTP server. Now this is when someone was having problems and complaining, saying that it was just taking forever to send email. So here's the DNS query going out to smtp.packetlevel.com. There's the response that came back, and there's the client going to make the handshake to the SMTP server. Now, whether our SYN packet never got there, or whether for some reason that server did not respond, it's not going to work. My gut feeling would be that the SYN packet never got there, because if the SMTP service was not running on that machine should have sent us back a reset saying, I'm sorry, I don't support that service, because at that point the SMTP daemon was not running. But in this case, we don't even see a reset coming back. So it feels like we do not have connectivity at all to the SMTP server. And we may want to validate that by doing an ICMP echo request, a ping, or maybe doing a UDP or a TCP trace route to that target system. The next trace I'm going to bring up is an SMTP verify. Now this is somebody running a verify to see if an email exists on an SMTP server, and this is somebody running to see if my email exists on our server. So we can see the handshake process takes place. Then we can see the server come back and provide its basic information. The client says EHLO. The server responds with the basic information about itself, as well as the information saying that it doesn't have a size limitation for email being sent, and that it will support pipelining. And pipelining is the process of where we tell the client they don't have to wait for a response before sending the next request. Now at this point we see the command RSET, and that's a reset. Now that reset is typically used when somebody aborts sending an email. Then that would just clear out any portions of the email that had been sent, anything that's buffered at the server. In this case the server says, okay, you want me to reset. And the verify command that's going across is vrfy. And the person will send across vrfy, and they will put in the email address that they want to verify. You can see on our SMTP server it does not support the vrfy command. Now we look at that and say, oh, that's really great that we don't support that command, nobody can verify our email addresses, but wait till you see what happens next. Here the sender sends the reset again, and the server says, okay, that reset was accepted. And now the user is sending an email saying that this email is coming from lchapel@packetlevel.com, and the command is mail. And here you can see the SMTP server says, okay, that's all right with me, I'll accept that. That sender name is okay. So the verification actually did work fine in this case. Now if we were on the outside of the company doing this from the outside, we might not get that message. So instead, as a precaution, they send a receipt to message to the server to say that they're trying to send to that address. And the server responds and says, hey, you know what, that's okay too. So they did do a verification of the email address, even though the vrfy command didn't work to do that. Finally, the person doing the verification sends out a quit command, and the server recognizes that's the end of the communication, and then we see the client system send a reset. You don't really want to see a bunch of vrfy commands hitting your email server. The last trace file I'm going to show you is one where somebody is doing an SMTP relay test on the server. It looks very strange on the wire. The trace file is called smtp-relay test 2. Now in here we have a lot of traffic other than SMTP traffic, so I'm going to type in SMTP just to pull out the SMTP traffic. Here we can look at the commands individually, but this is a case where there's a lot of information being sent back and forth here. So I'm going to right mouse click and follow the TCP stream so that I can see it all in one nice window. Again, this is one of my favorite filtering techniques. Here you can see a client sends an EHLO, identifying itself as a system called VIO. Server comes back and says, I don't have size limitations, I do allow pipelining. The client says reset, reset OK. And now the client system says, I want to send messages from spam test at packetlevel.com. And the email server says, OK, that's fine. And I want to send it to security test at packetlevel.com. And the email server says, OK, that's fine, I'll forward that. Then the client does a reset, and they try to send a message from spam test with no domain information at the end of it to see if the server would allow that. And when we were playing with this, we set up the server to allow that so that it would say, okay, that's fine, go ahead. Then they send a receipt to security test at, and the server goes through and says it's validating the sender. This whole entire process here has no actual mail associated with it. At no point do we see any actual mail data crossing the wire. All we see is this receipt to, mail from, receipt to, mail from, receipt to, mail from. And that's what it looks like when someone is doing a relay test. We can see an invalid recipient line, a set of invalid recipient lines coming back, because the server that they're trying to go through, when they say that they're sending it from, and they put in the actual server information there, and they tag on the at packetlevel.com, and they put it after the server's true name and everything, that won't be accepted. It will not work with this server. The interesting thing with this is that to look at the logs of our SMTP server, we can see exactly what happened. It comes up and we have a little alerting system that tells us that someone has just run a relay test on us. Typically that's going to be a spammer that's going to see whether they can relay through our SMTP server. So that's an example of one of the types of email patterns that you don't want to see. Now you could do a filter on the mail command by right mouse clicking and applying a filter based on the selected value. And there you can see all the different values that they tried out in sending this relay test.